Hey everyone, and welcome. Today we're diving into a classic coding challenge, merging two sorted linked lists. Now, it sounds simple enough, but trust me, the details can get really messy. The great news is there's a super elegant solution that might just change how you look at problems like this for good. So let's be real. Have you ever gotten completely tangled up juggling pointers, worrying about null checks, and just trying to figure out where to even start a new list? If so, you are definitely not alone. Pointer manipulation can be a total nightmare. But what if I told you one simple trick could make all of that frustration just melt away? All right, so here's our mission. We get two lists, and as you can see, each one is already sorted. Our job is to weave them together into one single brand new list that keeps everything in perfect sorted order. Simple enough, right? Well, while it sounds straightforward, the old saying is true. The devil is in the details. And this is exactly where so many of us end up writing really complex, bug-prone code, just trying to handle all the weird edge cases. Think about it. These are the hidden headaches, right? Like, where does the new list even begin? That very first node always seems to need its own special logic. And then what if one list is empty? Or what if they're both empty? All of a sudden, your beautiful code is just littered with messy if statements. It gets complicated, and it gets complicated fast. But there is a much, much better way. So let me introduce you to the secret weapon for a cleaner solution, the dummy node. This one simple idea pretty much eliminates all of those headaches we just talked about. So what on earth is a dummy node? Well, think of it as a temporary placeholder, a little helper node that we create and stick at the very front of our new list. Now, it's not actually part of our final data, but it gives us this perfect fixed anchor point to start building from. It simplifies everything. Okay, so here's a look at the code in both C++ and Python. Don't worry about memorizing every single line right now. The most important thing to notice is that very last line, return dummy.next. You see, we don't return the dummy node itself. We return the node right after it, which is the actual start of our beautifully merged list. All right, now for the fun part. Let's actually walk through this step by step and see how these pointers dance together. This is where the magic really happens. So we kick things off by creating our dummy node. Then we create another pointer, let's call it current, and we point it right at our dummy. This current pointer is the workhorse. It's what we'll use to actually build the new list piece by piece. Meanwhile, list 1 and list 2 are just sitting there, pointing to their first numbers. Okay, now we hit our main loop. And the logic here is super simple. We just look at the values at the front of each list and compare them. In our case, is 1 less than 2? Yep. So the node from list 1 is our winner. And because list 1's node was smaller, we attach it to our new list. How? We just tell our current pointers next to point to that node. And just like that, you can see our dummy node is now connected to the first real element of our merged list. Now, this part is crucial to get ready for the next round. We have to advance our pointers. First, current hops forward to the node we just added. That way, it's in position to attach the next element. And second, since we use the node from list 1, we advance the list 1 pointer to its next node. And boom, we're ready to loop again and compare the next pair. So why is this so powerful? It's because that dummy node gives our current pointer a place to start. We never need a special if statement for the head of the list. The first node gets added with the exact same logic as the 10th node. This pattern even handles empty lists for free. If a list is empty, the loop just doesn't run, and we just attach whatever is left over at the end. It just works. Now, that iterative approach is fantastic. It's efficient. It's what you'd probably use in an interview. But there's another way to think about this problem that many people find even more beautiful and elegant, and that's recursion. You've probably heard this old programmer joke, right? It perfectly captures the mind-bending nature of recursive thinking. It's all about breaking a big problem down into the smallest possible version of itself, and then just letting the solution build itself back up. So recursive logic always has two parts. First is the base case, the simplest version of the problem. For us, that's when one of the lists is empty. The answer is obviously just the other list. That's our stop sign. Then you have the recursive step. We ask our function, merge 135 and 246. It compares 1 and 2. Since 1 is smaller, the function says, okay, I promise to return node 1, and I'm going to attach its next pointer to whatever I get back from calling myself on the rest of the lists. So it calls merge on 35 and 246. See, it's a subproblem.
That second call then compares 3 and 2. 2 is similar, so that call promises to return node 2, linked to the result of merging 3, 5 and 4, 6. This chain reaction keeps going, solving one tiny piece at a time until it hits a base case and the whole chain of answers comes dominoing back up.
And when you translate that logic into code, it's just incredibly concise. Look at that. You can see the base cases right at the top. If a list is empty, just return the other one. Done. And that's followed by the simple comparison that decides which node to use for this step, and the recursive call that magically solves the rest of the problem for us. It's a really different way of thinking, but wow, is it clean.
So as we start to wrap this up, it is so important to see the dummy node for what it really is. It's not just some clever little trick for this one specific problem. It is a fundamental programming technique.
Here's the real takeaway for you. Anytime you find yourself building a new list or any kind of sequential thing, and you start writing special if this is the very first element logic, stop. That's your signal. That's your cue to use the dummy node pattern. It gives you a clean, universal starting line that just makes your code simpler.
And that really leaves us with a final thought to chew on. This whole technique is about creating a simplified starting point to make the actual process way easier. It's about taking one small step back so you can make a giant leap forward. So my question to you is, what other complex problems, in coding or really anywhere, could be solved by doing the same thing? By just starting one step back?